Okay, so we are going to finish up our section on radians and degrees. It is technically your 1.1 in your textbook. We have looked quite a bit at what radians are and how we get radians. Just to review back up here to our picture, we know that a radian is the length of one radius around the circle. So 2 radians would be 2 radius lengths around the circle. 3 radians would be 3 radius lengths. And then 3.14 radians takes us halfway around. And that's pi radians. Pi is halfway. Another half would be another pi. So 1 time around is 2 pi. That is our circumference formula. Circumference equals 2 pi r, or 2 pi radians. So just reviewing that, we saw different angles. We learned how to convert degrees to radians and radians to degrees. And then we saw some of the common angles and what quadrant things are in, like where would, 1 1/4 radians end up, and 1 1/2 radians is down here at this bottom. So 1 1/4 would be in quadrant 3 here. So just different things that we picked up so far. So let's take it a little further. A little bit further into our radians and talk about a little formula. So how we actually get the radians length. And the radian angle we use a lot is the letter theta. It's just a variable, it's like an x or a y. But in radians, they often use the Greek letters. So you're going to see alpha, you'll see the beta, and you'll see most of the time you'll see theta. And that's usually for a radian angle. Now, to get a radian angle, we need to take our arc length and divide it by the radius. So whatever your length of your arc is around it, you're going to divide that by the radius. So whatever this arc length is here, you're going to divide it by the radius of 10. So if I was to tell you that your arc length is 3 feet, okay, so if I move over to this picture here, and your arc length is, we know the radius is 10, and this arc length is just 3 feet. Okay, it's not 10. If the arc length was also 10, then that would be 1 radian, because it would be the length of 1 radius. But we have an arc length that's less than 10, so we're going to have less than a radius, or less than 1 radian. So if my arc length is 3 feet and my radius is 10 feet, if you took 3 and divided it by 10, you end up with 0.3 radians. 3 divided by 10 in your calculator is 0.3. So that is less than 1 radian because it's less than the length of 1 radius. The length of 1 radius would be your 1 radian. If I had a 5 feet, a 5-foot arc, so this arc, say now it's 5 feet. The radius is still 10, that doesn't change. The radius is 10 and the little arc length is 5, then you only did half of the radius, so you're going to have half of a radian, which is 5 feet over 10 feet is a half a radian, or it's also, we could call it 0.5 radians. So that's how you find your radian angles. Your radian angle would be your arc length, whatever the length of the arc is, and then divide it by the radius. Because a radian is coming from the term radius. So you're trying to find out how many of those radiuses would be around the circle, how many radii are around the circle. If you had a 31.4 degree arc, if this whole thing was 31.4 feet, and your radius again was 10, that means you would have gone exactly halfway around the circle, pi radians, because it would be 31.4 divided by 10, which is 3.14, or pi. That is halfway, exactly halfway around the circle. So that theta angle would be pi radians, or 3.14 radians, radii. So that's your arc length. That's how we get a radian. Okay, that's just the short term of how to get a radian. Now what I want to show you is just a couple of applications that we can use. Now, knowing what radians are, we can use it in applications. And it will help you on the homework because you're going to have a few problems where you need to do some applications. You got a couple word problems on it and stuff, so it will help. But we're going to have a term here called S. S is always arc length. So anytime you see S in our trig, it's going to be for an arc length. arc length, or if there maybe would be a quadrilateral or something that might be a side, but normally it's going to be arc length. And our formula to find the arc length is to just take the radius and times it by how many radians you have, which is basically how many radii do you have. Take the radius and times it by how many you have. That's a radian. So that's what we're looking for here. Now, we already learned how to find arc length in geometry. We said that you could do the part over the whole for degrees equals the part over the whole for the length. We already did that, and you can still do that if you want to. If you don't remember that your radius number times your radians gives you your arc length, you could still do the proportion if you want. That's not wrong. You're still going to get the same answer. So what I would want to do here is to get my arc length, I want to take my radius, which is 4, and multiply it by the radians. So I would have to take 240 and multiply it by pi over 180 to convert it to radians. To convert to radians, you're going to go 2 radians, so the pi has to be on top, the 180 on the bottom. You can divide by 10 to get rid of the zeros. 24 and 18, they both divide by 6, so it'd be a 4 and a 3. So your radians, 240 degrees, would be 4 pi over 3 radians. That's how many radius lengths 240 degrees would be. So that's my radians, 4 pi over 3. So my radius was 4. My radians is 4 pi over 3. If I multiply those two together, I put a 1 under it, I get a 16 pi on top, and I get a 3 on the bottom. Now, you wouldn't really want to say 16 pi over 3 inches. That's not a real proper way to say inches. So they need to want to get your decimal. So I would want to take that 16 pi over 3 and do 16 times pi equals, and then divide by 3 and get 16.76 inches. So that way we have at least, it's about 16 3/4 inches. Now I want to show you that your geometry would have still worked. You could have put in the 240 for degrees over the 360, your part over your whole in degrees, and the part of the circle is what we're looking for. That's our x. The whole circle would be 2 times pi times 4. That would be your circumference formula, 2 pi r. So again, I would reduce, divide by 10, get rid of the zeros. 24 and 36, you can divide by 12 and get 2/3. If I multiply diagonals, I get 3 times x, which is 3x. I get 2 times 2 is 4. 4 times 4 is 16. I get 16 pi. And if I divide by 3, magically, you'll see that we had 16 pi over 3 before. So we actually have the same exact answer, 16.76 inches. Whether you did it with your geometry method or you did it using the radius times the radians. You can do either one. If you just know that an arc length is the length, how many radians you have of that radius length, then you can just multiply them together to get the arc length. Or if you want to do the proportion and compare your degrees with your length, you can do that too. So that is one part. That's your arc length. Now we're going to take this example right here and apply it to the next one called linear speed. Linear speed is always how fast something is going. So in this case, they want to know how fast is the second hand of a clock going. How fast means how far and how much time. We know the time, it goes 60 seconds to go around. But how far does it go in that 60 seconds? Okay, so our arc length, the arc length we have is our S number that we just learned the formula for. The S was the radius times the radians. And then we're going to divide that by our time. That's going to give me the linear speed. So what's the radius of my clock? Radius of my second hand we have is 10.2. How many radians we going? How many radians are you going, and it takes you all the way around the circle? 2 what? 2 pi. Yeah, 2 pi radians gets you around the circle. So times 2 pi. Okay, that's basically 2 pi r right there. That's your circumference, isn't it? Isn't that 2 times pi times radius, 2 pi r? That's your circumference, okay? So that's your arc length. You're doing a whole circumference starting here and going all the way around is one full circumference. Okay, you're going to divide that by 60 seconds because it takes that long to get around. So let's do that in our calculator. Wait, that was our S. So this is our linear speed. Linear speed equals, and let's do 10.2 times 2 times pi equals, and then divide it by 60. And you get 1.068. You know, it feels good when you get an answer, but if you don't know what that answer means, what good does it do you? So what is 1.068 telling me? But what? What is the units? What does that mean? 1.068. Okay, good. Centimeters per second. That's how many centimeters that second hand goes every second. So we know the second hand's moving, we just don't know how much it's moving. Now, it could change if the circle's bigger, that's going to move more each second. Okay, because you're just breaking your circle up into 60 seconds, right? So they go farther, it'll be faster per centimeters per second if you had a bigger circle, because you'd be moving more. But your smaller circle would be moving less. So this is going 1.068 centimeters per second. Okay, so that's called linear speed. Linear speed is always going to be a unit over a time. And in this case, our unit is centimeters, our time is seconds. All right, let's look at the Ferris wheel. It says a Ferris wheel is 50-foot radius, makes 1.5 revolutions per minute. A, find the angular speed. B, find the linear speed. So we already know how to find linear speed. We just saw that right over here to get linear speed. Angular speed, though, is how fast is the angle moving. How fast does the angle go as it goes around? So that's what angular speed is. Angular speed is going to be your central angle divided by your time. So what we would have to do is decide, okay, what are we going to use for the central angle, and what are we going to use for the time? Well, our time is what? What does that say right there? Per minute. You could actually make more sense. It might be to go per second. So we already know our time is going to be a 60 seconds. I could have put 1 minute too. It just makes the number bigger. I'd rather use seconds. But what's my central angle? 1.5 revolutions is my central angle. What's 1.5 revolutions in radians? Think about 1.5 revolutions. Close. Remember, halfway around is pi. Another half is 2 pi. That's 1 rotation. So another half is going to be 3 pi. So you got every half a circle is a pi. So 1 pi, 2 pi, 3 pi would be 1.5 rotations. So my theta is just 3 pi. So if I was to take 3 times pi and then divide it by 60, you're going to get 0.157. But that doesn't do you any good unless you know what that means. 0.15 second what?
Revolutions per minute.
Revolutions. What is 3 pi?
Half of the. Oh wait, no.
Radians. Thank you. 3 pi is radians. So it's 0.15 7 radians per second. That's how many radians the angle's moving as it goes around. Moving that many radians in every second. So it's a really small amount of radians. Remember, 1 radian would be 50 feet. So it's not even going probably like 4 or 5 feet maybe. Well, let's find out how many feet. We're going to do that right now in linear speed. Linear speed, we need to take our s, and s we know to be the radius times the radians, and we're going to divide that by time. So radius is 50. What was the radians again in this one? What did we use for radians up here?
Pi.
3 pi, because that's 1.5 rotations. So it's 50 feet, and it's going to go 1.5 revolutions, which is 3 pi radians, and we're going to divide that by 60 seconds. So let's take our calculator. 50 times 3 times pi equals, and then divided by 60. 7.85. So what is that 7.85 telling me? How many feet per second? How many feet it goes every second? How many feet per second? So look at the floor. Each tile is a foot. Okay, so do you see the tiles on the floor? 8 of those feet in 1 second. Is that fast or slow? Can I jump 8 of those in 1 second? Probably. It's probably not going that fast. I would say maybe one side of the room to the other side of the room in a second would be fast. That might be like a bike tire or a tire on a car. 7.85 feet every second. It's not super fast because it's 8 of those things in one. It's fast. It's moving. It's just not moving like moving. All right, so that's angular speed, how many radians in a second, and that's linear speed, how many feet in a second. The last one is your area of a sector, which again we did in geometry. And I have to admit, the geometry one might even be easier, but I will show it to you. There is a formula that now, since we know radians, we can now use a formula. It might be that it'd be hard to remember the formula, so you might want to use the geometry one, which was part over whole equals part over whole. And it was the degree part, and it was the area part. If you remember, we did a degree fraction, and we did an area fraction. But let's look at the formula first. It says sprinkler on a golf course fairway is set to spray water over a distance of 70 feet. So that means its radius is 70 feet. Okay, and it rotates through an angle of 120 degrees, so it doesn't go all the way around. It goes back and forth at the 120 degrees. So it goes over and then it comes back, and then it goes over and then it comes back. It's 120 degrees. Now our formula has radians though. So we're going to need to take the 120 and multiply it by pi over 180 to get it into radians. We want to go 2 radians, the pi has to go on top. The zeros you can divide by 10 and cancel out. And 12 and 18 you can divide by 6 and get a 2 and a 3. So you're actually going to get 2 pi over 3 radians. So if I was to use my formula down here, the area would be 1/2 times the radius squared, 70 squared, times the 2 pi over 3 radians. So that would be easy to multiply together, I think. If you can cross cancel the 2's and make them both 1's. And then 70 squared is 4,900 if you do 70 squared. And then you're going to just have a times a pi on the top, and then the bottom would have a 3 on it, because this was 70 squared over 1. So the bottom would have a 3, and if you multiplied 4,900 times pi and divided it by 3, you get 5,131 feet, or 0.3 square feet, because it's area. So this formula can go pretty quick, but you'd have to remember the formula and you would need radians. You've got to change it to radians. I do think that the geometry way might be a little bit easier, because your degree part would be 120 over the whole 360. We would be looking for the part of the area, and pi times radius squared is the whole area, pi times 70 squared. And if you reduce the 120 and 360 by 10 first, And then 12 actually goes into 360 3 times. So you get a 1/3 there. So 3 times x would be 3x. And let's see, this is just a 1 up here. So there's nothing up there. 1, it would just be pi times 70 squared, so it would be 4,900 pi. And if you divide by 3, you get the exact same answer we had here. So you would still get the 5,131.3 square feet. So it is a little tougher to remember this formula right here. That is a little bit tougher. But geometry way always works. So if you know an angle and you know a radius, you can easily solve for the area of a sector. All right, that's it for section 1.1, the degrees and radians.